Hello everyone, and in this video we are going to solve a question called binary tree level order traversal using a recursive approach. In the last video we used an iterative approach to solve the problem, and in this video we are going to use recursion to solve the problem. So level order traversal. What is level order traversal? Basically, in a binary tree, the level order traversal is same as breadth first, where you are going from left to right first, instead of going like depth first, where we like 3, 9, we go down all the way and then start printing it. Instead of doing that, we just print level by level, left to right, left to right. While depth first, you're gonna go 3, 9, and then you go 20, 15, all that. So alright, so how would you implement that recursively? Because, for example, doing depth first search using recursion is easy, right? So for example, if you just call traverse, so if you keep calling a function to the right, left, traverse, right dot, root dot, right, if you do that, this would just keep going down, right? Like it's gonna go down all the way to the left until it gets to here. But and we have to instead go 9 and 20. But like we can't just make it like that, right? So it has to be some smart, or it has to be some smart way implementing of the recursive solution for breadth first search for level order traversal. Okay, so how do we do that? So the first thing is to create a function that gets the height of the root. So you have to know the height of the root. So the height here is 2, 1 and 2. So and in order to do that, you create a function. So it's pretty easy. So you check if there is a root. If there is a root, be 1 plus, and you call that. You take the maximum of left and right, because so left here, for example, is 1, right? The right side, however, is 2, so 2 would be the maximum, and it would just give you 3 here. So you got height 1, 2, 3. All right, so now once you do that, so here's my function. I have a response. Now I'm gonna check if there is root. So in case we are past the root, that's none. That should return empty array. So now I'm gonna call that get height function, and I get the height of the root. So if I just print height, right, also like this is height of the tree basically, and you can see that the height of the tree is 3. So you see here the what they passed was 3, 9, 20, so that's the same tree they passed and to our program, and then the height is 1, 2, 3, right? Okay, so once we get the height of the tree, what we're gonna do? We're gonna do the for loop based on the height. So it's, since it's 3, the for loop there will be 3 times, right? It's gonna loop 3 times. So since it starts at 0, we are gonna pass in, we say I plus 1. When we, okay, so first I create a sublist. So because the way they want me to return the level by level, each level should be inside a list. So that's why I have a sublist here, the empty sublist. For the first time, for I in the range height 3, which is height equals to 3, first time I would be equal to 0, right? So I create my sublist, and I call the function print level. So print level is the one that basically goes through level by level and then appends it to a sublist, appends the result to a sublist. So what do we pass into that? We pass the root, which is the root is 3 at this moment. So 3, right? So and then we pass in I plus 1, because it starts from 0, so we are saying I plus 1, and we pass out sublist, which is empty list. So and then this print level function gonna use that to append all the level elements. Okay, Now let's go ahead and look at our print level function. So we just called it here, right? And just remember I equals to 0 and our root is equal to 3 and the sublist is empty. Now we are going to go here and it checks if root is none. So if our root is none, 3 is not none, so we're going to go to the second part, if level is equals 1. So the level we passed, okay, it's not 0, it should be I plus 1, so it's 1, right? So anytime we see a level of 1, then that's when we print or we append our result, the value of the 3, so the root. So that's why I'm saying sublist.append root.value. Once I do that, I don't have to go to left and right children of the root, so I just return nothing, and then once it returns it, we go back. Now our sublist contains 3, right? Now we append that to our response, so our response is going to have 3. Alright, but now we're not done yet with the for loop, so we're going to go up again, and this would turn into 1, right? Now we call now sublist empty again, the second level, and we print level, and then we say I plus 1. So I plus 1 would be 1 plus 1, which is 2, and our root would be still the same. It's still going to be 3, and our sublist would be empty. Alright, now that kind of gets interesting. So now let's look how everything works here. Now root is not none. Root is not none, right? So we're going to go, if level is now 1, so we're not going to append anything here. So we not append the root here. We're not appending 3 anymore. So that's when this is not true. So we're going to go down to print level root.left. So we're going to call this the same function again, right? So so you should remember that the level value would get appended to a sublist only when the level is equals to 1, right? So now we're gonna call the same function again with a root.left. So it's gonna call it with 9, right? Root.left is 9. So it's gonna call it with 9. And level minus 1, remember our level is 2, now minus 1 would be 1. It's going to give it a level of 1. See that? It kind of gets interesting, right? Because if level is 1, it's going to get added to a list. So alright, so we did that, and then we also pass a sublist into it. Our sublist is empty. Now this this function, this one's gonna wait until this recursive call is done. So this recursive call, once it's done, then we go to the next one. Alright, so this is called, and where do we go? We're gonna go to the beginning, and our root is 9. So if root is not, it's not none, so we're gonna go level. As you see, our level is 1 because we passed level minus 1. So here the sublist would we're gonna append the value of that root, which is 9. So the left of root right here, and we're gonna append that to a sublist. And once we are done, we return nothing, right? Then we're done with that. Now it's gonna go back, and then it's gonna call the other one, right? Now, but in the meantime, our sublist has 9. Now the second call, it would be, remember here our root is our level is 2, our root is 3, right? Now we're gonna call the right of the root function, which would be root of right is not 20. See if you look at this tree, and the level minus 1, our current level is 2, and 2 minus 1 is 1, and the root is 20, level is 1, and the sublist we are passing has already 9 in it because we called this function and it's added the left child. So 9, so so you probably guess the next value in this sublist should be 20, right? So because we call this function and then the current function gonna wait until this is done, so it's gonna go here, go on the top again. The root is 20. 20 is not none, so but the level is 1, so it just appends 20 to the sublist and returns nothing. So we are done with this, right? With the function, and this one is done and returns this print level function returns nothing. So here, however, it changed the sublist. Now our sublist contains 9 and 20, right? So and then we go response dot append the sublist. So that would be a 9 and 20. However, the third loop would get a little interesting because currently we are at the second one because we are at the, so it's 1, right? We start at 0 and now this 1, and then we appended that sublist. Now our last I would be iterator would be star 0, 1, and 2. So currently our iterator is 2. Now sublist, we generate another sublist. So our goal is to have 15, 7, right, on the next recursive call. So here we print level, and our root is still the same. We still have 3, and our I plus 1. So that would be I plus 1, which I is 2, and that would pass 3, the height 3. So it specifies this part. So this is the first level, second, and then this third. So that's why we do I plus 1, because I in a for loop starts from 0. That's why we always do plus 1. So a sublist we pass in is empty. Alright, now we're gonna go to print level, and we are checking if root is none. Our root is 3, it's not none. We are gonna go if level is 1, our level is now 1, so we're gonna call this function again. Now pay close attention. Now print level root dot left is 9, right? And level minus 1, it was 3 minus 1, which is 2. So if you remember, we've already added that 9 and 20. We already traversed through 9 and 20. So will it append those values again? Now let's take a look. Pay close attention. That's the main part of this algorithm. It's very important to understand. Alright, 9, 2, and the last one is a sublist, which is empty. So we're not gonna go to the next line until we finish this function call, right? So in order to do that, we're gonna go to the top. We're gonna call, so it's gonna call this function. It's passing 9, 2. Alright, so it's checking if our root is 9, if root is not 9. So our level is 2, right? Our level is 2 because we are level minus 1, 3 minus 1 is 2. So it's not gonna print anything, and it's gonna call another, as you see here, it's gonna call another function to the left. So it's gonna call the left of 9, right? It's going to call left of 9. So root is 9, and it's going to call left of 9. And notice how level is decreasing. It's once it becomes 1, then we print it, right? Just remember that. So we are decreasing it, and level minus 1 becomes 1, and then root dot left would be the left of 9, which is none. And it's going to call this again, and we get to here and it returns nothing. And we're going to go back up to 9. That's the recursive function call. We were stuck at 9, so here, right? Now we're going to call its right with level minus 1. Our level is 2 currently, and 2 minus 1 is 1. That's going to go here. The root is 9, none, so we return nothing. So that's how we are printing the third level. That's how we are skipping the first and second, and then it's going to go down by calling itself and by saying level minus 1. Now, so there's no left and right child on none, right? So this returns, so it's going to go to the next line, where our root is 3 as usual. So this one returned nothing, right? It returned nothing. So we went, remember, we called that function, we went down and we called this again and the second one, and both of these were none. So the left of 9 was none, and the right of 9 was none. So we returned nothing for the function call where we called the left of 3, which was 9. Now this returns nothing, so there's nothing appended to our list. And then we are going to go to the print level root right, which would be the right of 3, which would be 20. Now, so basically passing in 20, level minus 1, which our level is 3, remember. Now 3 minus 1 would be 2, and our sublist would be empty. Now, as you notice here, we're going to go for this, we call this function again, right? Now it checks if root, if 20 is none, it's not none. So level is 1, level is 2, so it doesn't work. So that's why we're not going to print 20. And then after that, we are going to call the left child of 20, which is 15. And currently, the root, the level at 20 is 2, right? And then we level minus 1 and make it 1. So it gets to here and calls another function. So here, comes here. So we called this, right, with the root 22. And then it goes here, this is false, and it calls left again. The left child of 20 is 15. And then the level minus 1, the level was 2. Now the level is 1 and the sublist, right? Now it's going to call this function. It's going to go here. If root is none, if level, now level is 1, so it just appends 15, right? Once it appends 15, it returns nothing. It's going to go back to the function call where we made with 22 was this. It's going to call its right, which is this function, and then it's going to decrement the 2, the level, that would be so that would be 7. So we call the root would be 7, a level would be 1. So it's going to go here and appends that value to a sublist. So the sublist 7. So sublist is going to have 15 and 7. And then we're going to go back to the top function call, which was that's what we started with, right? Was 20. And then this is done, and then we are done basically. And we're gonna go to the top here, and now our list has 15 and 7, and then we just append that 15 and 7 to the sublist. And we are good to go. That's why, and at the end we just return the response. So it was easier. So if you just like at your third iteration in the for loop and your level is 3, you are gonna basically skip the top 2 levels, and then you decrement your level here. You're decrementing your level, and once it becomes 1, then it starts printing those 15 and 7. So it's very important to understand that how things are working. At the beginning it was 3, right? And the level we passed, the for loop started at 1, right? We passed 1. I was 0. That's why it printed 3. It added 3 into a list. The next time we did it, our I was 1. So it was 1 plus 1, 2, right? And then we got here, this wasn't true anymore. So we decremented the level and passed the left of root, which was 9, and then 9 got appended, right? And we did the same thing, and we passed the right of 3, 20, and then the level was decremented to 1, and then we appended that, and 9 and 20 got into the list. And then we went back and then our I became 2, and then it was 2 plus 1, and it skipped the first 2 elements, and by skipping it we also decreased the level. The first level at the beginning was 3, so 3 minus 1, we ended up with 2, and here it was 2 minus 1, and then the level was 1 in here, and then when we call this function 15 and 7, it checked if their level is 1, so level was 1, and then appended them. So yeah, that's how we skipping the levels. We are decreasing the level by 1 every time. So that's it for this problem. It's just you have to think recursively to really understand the problem. If you can't do it, just draw each recursive call and think about it, and it would really make sense. That's it for this, and I'll see you guys in the next video.